dissect the tissue on when it comes in. So as you can see, if I put a piece of paper on, there's a suction that sucks any particles into the thing, and it's all kept neutralized. So this is just a example of where so this is what a fresh brain looks like when it comes into the tissue bank. And this is just a catalogue just to help people if they're dissecting at 2 in the morning that you might need some refreshment. So this is from the top. So this is on the side view, and this is the base of the brain, and this is where it's attached to the spinal cord. So you can see this, you might be able to see just this bit here which is curled around.
Yeah.
That's your olfactory bulb, which is connected to your sense of smell. And these white stalks here would normally be connected to your eyes. They're the optic tracts. And you can see here the line of pigmented cells, which is a substantia nigra. So you can see those with the naked eye. So in a Parkinson's case, this line would be much, much paler. So it would indicate that you've lost these pigmented cells.
You actually can see it with the naked eye.
Well, you can see the line of cells, you can't see the cells themselves.
Sure.
So let me just show you. So then what we do is we separate the two hemispheres. One side goes into what we call a fixative solution, and then the neuropathologist looks at that later on. The other side we then slice into 1 centimetre thick slices, which I'll show you next one. So there's a slice. So it's a beautiful structure. And then what we do is we use this grid pattern here to actually block the tissue into these squares.
This is a normal brain, not Parkinson's.
Yes, it's normal. Yeah, because we have the Parkinson's one exactly the same.
Yeah.
So yeah. So these blocks then get frozen in that supercooled liquid, and because of the size, that they freeze very quickly, uniformly, and every cell within the block is preserved as it would be inside your head. And this is the cerebellum, which is the back of the brain. It's another area, which again is very beautiful structures to it.
Is it literally cut with a knife?
Sorry?
Literally cut with a knife?
Yes, it is nice with a knife. And it's like a bread knife. Yes. Yeah, it's quite soft. If you can imagine the consistency of your brain, it's like a very thick set blancmange.
Like liver, is it? Same?
Yes, like liver. Yes, so it is quite soft, but you can, with these very sharp knives, yeah, so you can cut it. And this is why we need to collect the tissue very quickly, because if we leave the tissue in the patient for too long, it starts to become much too soft to really handle, because it starts to degrade.
So you don't waste any bit of the brain, every bit?
Everything is kept. Yeah. Yeah. And also, we take the spinal cord as well, although some hospital technicians aren't sort of qualified to take the spinal cord, because there are some changes that you can see sometimes in the spinal cord. Okay, right. Now, I may have a